Welcome to my YouTube channel, a Brainery of Civil.
Today I am going to solve the fourth assignment of Strength of Materials. The first question is, a bar with circular cross-section having modulus of elasticity E, length L and corresponding cross-sectional area A is fixed at one end and free at other end. So you can have a diagram here. So that is, it has been fixed at A and free at B. If it is subjected to temperature rise of delta T, so that is, initially the temperature will be T1, after some time the temperature has been increased to T2, the change in temperature he has given it is delta T in the system due to temperature. Considering alpha is coefficient of thermal expansion is, so the stress induced, so the stress will induced only when both ends of a member are fixed. If one end is fixed and other end is free, that is, if by increasing the temperature, the member can able to extend however it requires. Okay, so in that case, there is no development of stress in the member by increasing the temperature. Clear? So, the stress developed will be 0 for this question. Answer is C for question number 1. Next question. The determination of temperature induced stresses in an axial bar with fixed ends subjected to temperature variation is, for example, a bar which is fixed at both ends. So when a bar is fixed at both ends, so at fixed support the number of reactions are 3, here are 3. Okay, so total number of reactions is equal to 3 and number of equilibrium equations is equal to 3. Obviously this is degree of static indeterminacy is 6 minus 3, that is 3. So it is statically indeterminate problem. Okay, and here we can use how much stress developed, we use some compatibility equation. So compactability equation is free expansion minus elongation due to fixed reaction. So there is a reaction at fixed end is equal to 0. So that is L alpha delta T is a free expansion minus RA, that is sigma L by E is equal to 0. By this you will get sigma is equal to E alpha T. So E alpha T stress will be developed when both ends are fixed. If one end is fixed and other end is free, there is no development of a stress. Here we use compactability equation for statically indeterminate problems. Statically determinate problems are solved only by using just equilibrium equations. When equilibrium equations are not sufficient, we go for compatibility equations. So here we have used the compatibility equation. So it is a problem related to statically indeterminate problem. So the answer B for question number 2. Now coming to question number 3, for a system of plane stress condition. Plane stress condition is something like, generally the 3D matrix, strain matrix is epsilon xx, epsilon yy, epsilon zz. This is pi xy by 2, this is pi yx by 2, this is pi xz by 2, this is pi zx by 2, this is pi yz by 2, this is pi zy by 2. Okay, so this is a 3D matrix. Plane strain condition means you will get only epsilon xx, pi xy by 2, pi yx by 2, epsilon yy, remaining all the terms are 0. So that is, in the direction and in the plane of z, all the strain elements are 0. Irrespective, they may be a shear strains or normal strains. So the number of components here are epsilon xx, epsilon yy and pi xy. So 3. Okay, option B for question number 3. Now coming to, he has given epsilon xx, epsilon yy and epsilon xy, generally it is gamma xy. Determine axial strain at an axis inclined at 30 degrees. So this is anti-clockwise direction. Theta is equal to 30 degrees he has given. Now anti-clockwise direction. So he has given the strains in this plane and he rotated anti-clockwise direction by some angle 30 degrees. So in this plane axial strain we want. So axial strain at 30 degrees anti-clockwise is equal to epsilon x dash is equal to epsilon x cos square theta plus epsilon y sin square theta plus epsilon xy cos theta and sin theta. So epsilon x is 100 into 10 power minus 6 cos square 30. Epsilon y is 50 into 10 power minus 6 sin square 30 plus epsilon xy is 20 into 10 power minus 6 cos 30 into sin 30. So you will get this is 96.16 into 10 power minus 6. So this is generally the nearest answer is 106.10 power minus 6. Option D for question number 4. Clear? And next question. At a point in a loaded member, the state of plane strain exists and strains are epsilon x, epsilon y, gamma xy with the elastic constants mu and g respectively. The normal stresses sigma x, sigma y we need to calculate. Okay. So the basic principle we need to know here it is on any two perpendicular planes the summation of normal stresses is a constant value. For example, this is sigma x, this is sigma y and this is a principal plane I am taking. So perpendicular to this plane there is another. This is sigma 1 and this is sigma 2. So from the concept that sigma x plus sigma y is equal to sigma 1 plus sigma 2. In any plane on a particular element, summation of normal stresses is constant and is equal to summation of normal stresses in another plane. It may be a principal plane or whatever it is. Okay, this point it will help here. So and he has asked sigma x and sigma y. First of all, by using strain in x direction, y direction and shear strain, we can calculate major principal strain and minor principal strain. So that is major principal strain E1 or minor principal strain E2 is equal to Ex plus Ey by 2 plus or minus Ex minus Ey by 2 whole square plus gamma xy by 2 whole square. Okay, so you will get E1 is equal to 344.56 into 10 power minus 6. This is major principal strain. And E2 is equal to minor principal strain minus 164.56 into 10 power minus 6. Clear? So, by using this major and minor principal strains, we will get major and minor principal stresses. That is, sigma 1 is a major principal stress. We have a formula E by 1 minus mu square E1 plus mu E2. If you substitute the required values, you will get sigma 1 is equal to 64.73 and some other value. By substituting this sigma 2 E1 by mu square E2 plus mu E1, you will get this is 16.729. Clear? So the summation of this sigma 1 plus sigma 2 you will get it is around 81.46. Now sigma x and sigma y values sum will be 81.46. If you will add this 23 plus 57 it is around 80.8. So approximately this sum is equal to sigma x plus sigma y. So the answer for question number 5 is C. Okay. So here I have not calculated the values of sigma x and sigma y. I just checked the values from the options. So for what options the summation will be is equal to the summation of sigma 1 plus sigma 2. That will become the answer. Okay. Next question. For a physical system, the maximum shear strain coincides with the pure shear strain when. So already this concept I explained in the earlier problems that the maximum shear stress coincides with pure shear stress. So in that case, the principal stresses are equal in magnitude and in opposite direction. When the principal stresses are equal and opposite in direction, then the condition will be satisfied. For question number 6, answer is A. For question number 7, a cubical element is subjected to following stresses sigma x, sigma y, sigma z. Okay, so that is he has given sigma x is equal to sigma y is equal to sigma z is equal to 5 MPa. So maximum shear stress tau max will become major principal stress. So whenever he has not given any shear stress, the given stresses are nothing but principal stresses. Sigma major minus sigma minor by 2. Sigma major and sigma minor are always equal to 5. He has given, according to this will become maximum shear stress. When maximum shear stress is equal to 0, according to this, G is equal to tau max divided by gamma max. Okay. When tau max is equal to 0, gamma max is also 0. So that is option C for question number 7. What is the volumetric strain for isotropic material with Poisson's ratio? So with Poisson's ratio mu is equal to 0.5. Volumetric strain epsilon V is equal to. We have a formula for volumetric strain epsilon V is equal to 3 sigma by E 1 minus 2 mu. That is 3 sigma by E 1 minus 2 into mu is 0.5. So you will get it is 1 minus 1. So there is no epsilon. There is no volumetric strain for isotropic material having Poisson's ratio 0.5. So the answer D for question number 8. Now a cubical element is subjected to following state of stress. He has given sigma x is equal to 80, sigma y is equal to minus 20, sigma z is equal to minus 30, and along with this tau xy is equal to tau yz is equal to tau zx. All are equal. So that is, there is no shear stress on the planes that he has given. When there is no shear stress, the given stresses are nothing but it is a principal stresses. Okay, and he has given E 2 into 10 power 5 and mu is equal to 0.25. Clear? So from this he asked us to calculate maximum shear strain. First of all, we will calculate, he has given principal stresses. We can calculate principal strains easily. So E1 is equal to sigma x, E1 is equal to, that is nothing but it is Ex minus mu sigma y minus mu sigma z by E. If you will substitute the values, you will get sigma x is equal to 4.625 into 10 power minus 4 and E2 is equal to, that is equal to Ey. Sigma y minus mu sigma x minus mu sigma z, that is equal to by E is equal to minus 1.625 into 10 power minus 4 and E3 or Ez is equal to sigma z minus mu sigma x minus mu sigma y by E. So that is equal to minus 2.25 into 10 power minus 4. So this is major principal strain. This is minor principal strain. So if you add these two, so that is maximum shear strain epsilon 1 minus epsilon 2, that is major minus minor. 4.625 minus of minus 1.625. So you will get it is approximately 6.25. So the answer C for question number 9. Okay. Coming to question number 7, he has given EA. This is along x direction, it will become Ex. 7 into 10 power minus 6. And EC, that is equal to along y direction, it will become Ey. And it will be 4 into 10 power minus 6. And gamma xy by 2, we have a formula EB minus EA plus EC by 2. Okay. So this is EA, this is EB, this is EC. So what is EB? 2 into 10 power minus 6 minus 7 plus 4 into 10 power minus 6 divided by 2. You will get it is minus 3.5 into 10 power minus 6. Clear? So by this he asked us to determine principal strains. So you know everything. E1 or E3 Ex plus Ey by 2 plus or minus Ex minus Ey by 2 whole square plus gamma xy by 2 whole square. So if you will take positive, you will get it is E1. If you will take it is negative, you will get it is E3. So you will get E1 as 9.307 into 10 power minus 6 and E3 as 1.692 into 10 power minus 6. Clear? So the answer will be option C for question number 10. Next question. So in this question, he has given displacement field. So the coefficient of I will become U. The coefficient of J will become V. The coefficient of K will become W. So that is U is equal to 3y square, V is equal to 6yz, W is equal to 5 plus 8x square. Shear strain you will have some separate formulas. Gamma xy is equal to dou u by dou y plus dou v by dou x. So here u has to be differentiated with respect to y, v has to be differentiated with respect to y. Generally u, v, w are corresponding to x, y, z. So when you are calculating this shear strain in xy plane, so you will have terms u and v. U can be differentiated with y, v can be differentiated with x. Okay, it's very easy to remember the formula. So dou u by dou y, if you differentiate 3y square, it will be 6y. Dou v by dou x, there is no x term in the v, so it will become 0. So and when you put the point P here, so 1, 2, 0, you will get it is 2. 12 into 10 power minus 6. Here 10 power minus 6 minus 2 is there. Okay. So it will be 0.12. Clear? Similarly, gamma yz is equal to yz dou v plus dou u v w. W has to be differentiated with respect to y. V has to be differentiated with respect to z. That is dou v by dou z you will get it is 6y. Dou w by dou y you will get it is 0. Again it is 12 into 10 power minus 2. That is equal to 0.12. And gamma xz, that is dou u by plus dou w by. W coefficient will be z. U coefficient will be x. So you will get it is dou u by dou z 3y plus dou w by dou x. It will be 0. 16x. It is 16 into 1. It will be 0.16 because it is 10 power minus 2. So the strains are 0.12, 0.12, 0.16. Answer D for question number 11. Now the last question is, a rigid block ABC weighing 200 kN is supported by 3 rods symmetrically placed as shown in figure given below. So left side and right side there are 2 steel rods and in between them there is a bronze rod. He has given length of steel and bronze and the area of cross section, length, modulus of elasticity and coefficient of thermal expansion. So it is somewhat a long answer question. थोड़ा ध्यान रखो इधर, ठीक है, we will get a proper answer. So now this is bronze, these both are steel. So I am just drawing a free body diagram. So if it has to be in horizontal, this is A, this is B, this is C. Whenever it has to be in horizontal, there are 2 types of deflections. Deflection because of temperature, deflection because of load. These 2 should be equal in steel as well as in bronze. When the deflection is equal in both the materials, then only the beam will be in horizontal. But the total deflection is equal to delta temperature deflection, that is delta load because of load deflection. Okay. So now I am taking Fs in force in steel bar and Fb force in bronze bar. Clear? So now this deflection I am equating in steel as well as in bronze. So first of all, temperature deflection is length of steel, L alpha of steel and delta T, L alpha T. It is temperature deflection in steel, and because of load, force into Ls divided by As into Es, that is FPL divided by it is because of load. That is equal to Lb alpha b delta t plus FB LB AB into EB. So if you will substitute these values, you know L alpha delta T, L alpha delta T, LS, AS, ES. You can get an equation like 4.878 Fs minus 12.2 Fb, that is equal to 360. And from the equilibrium equation, you will have one more equation like two steel bars, two types of force plus force in bronze. These three has to be carried by 200 kilonewton. By using this 1 and 2 equations, you can get force in steel is equal to 95.634. Force in bronze is equal to 8.73. Okay, now stress in steel is equal to force in steel divided by area of bar in steel. 95.634 divided by area of steel is 1000. It will become 93.634 Newton per mm square. Okay, or else it is in MPa. And sigma s is equal to 8.73 divided by 1500. It has in kilonewton, so into multiplied by 1000. So you will get it is 6.2 MPa. Okay, so the answer is somewhere around, it will be option B for last question. Okay, so these are all the answers for assignment 4 in strength of materials. Thank you.